So in this example, we have a number of state variables, right? Number of state variables equals 2. So because we have two energy storage device, right? L and C. That's why we have two state variables. So how do you write equation associated with this L, the differential equation, and also differential equation with this guy? So what do you, can you imagine a differential equation for this guy? So voltage across L is given by VL equals L di L over dt. This is the one of the differential equations here. So the other one here is, so IC equals C times dVC over dt. Now we have two differential equations here, one related associated with L and the other associated with C. Okay, so from here we can guess that these two are IL and VC. They are state variables, right? So IL and VC are state variables. So we figured out state variables. Now the thing is, now what is on the right hand side? Right hand side is IC, okay, and VL. Now our goal is to write this IC and VL in terms of state variables, which is IC in terms of BC and IL, and VL in terms of IL and VC again. If you can, try to include as many state variables as possible here. So at most we can do two of them, right? We can include VC and IL. At most we can include IL and VC. Try your best to include these two guys. In other words, try to express this guy in terms of these two state variables and the input here, VT. And also these state variables and VT. That will be your second step. Okay. So for that, what did you do? We just use the Kirchhoff's law, right? So if you use the Kirchhoff's law, let's say there are two Kirchhoff's laws, right? So one is current, the other one is voltage. Kirchhoff's KCL and KVL. KCL and KVL. So here, at this node, right? So let's use the Kirchhoff's law. What do you get? You have IL going in, right? Going in, IL plus. Then going out, minus IR. Then going out, minus IC equals 0. So then in that case, your IC equals what? Because I need to write IC, right? So what is your IC then? IC equals, help me here, IL minus IR. Okay, this is what I have here. Then I can again write IR because I have written in terms of in terms of IL, but if I want to write this guy also in terms of VC. Can I write this guy in terms of VC? Because my state variable is VC and IL. So I have IL here. Now can I write this guy in terms of VC? So IR is the current through here, right? What is the voltage? Suppose voltage here is VR. Can I write my IR equals VR over R? Ohm's law. So now VR is equals VC because VC and VR are in parallel. Okay, so that's why my IC equals IL minus this IL minus IR is VC over R. VC over R. So I have IC like this. This IC is this guy here. Okay. Now, similarly, what is your BL? Now, let's write this BL in terms of IC. No, BL in terms of IL and BC. BL in terms of IL and BC. So how do you write that? So let's begin with Kirchhoff's voltage law. So what is Kirchhoff's voltage law? So use this voltage law here, right here. If you use this here, then what do you get? Help me figure out. So you have BT here. Then what is the voltage here? We can call it BL. What is the voltage here? You can call BR, or this BR is equal to BC. Can I simply write BC? Equals 0. Now let's choose the sign. So from here to here, you're going uphill. This is plus. From here to here, you're going downhill. This is minus. From here to here, you're going downhill, minus. So your VL equals to what? Because you need VL, right? VL equals VT minus BC. Does it make sense so far? So this is what it is here.
Looks good to me.
Okay, good.
Oh, I'm sorry, Professor. Would you mind? Oh, thank you. Just for a second.
All right, that's fine. Take your time.
So did you say that we were also trying to write VL in terms of VC and IL?
Yes.
Okay.
Thank you. I got it.
And also, if you can, in terms of VT also, if you can, try your best to write any variables in terms of, this is your goal, any variable in terms of state variables and input. That's our goal. So you have to try your best to express any variable in terms of state variables and input. So state variables are BC and IL, and your input is BT. So we have BC and BT already. So I don't think we can do any further, right? Because it's already expressed in terms of input and state variables. Now you have to plug this in now. So we have to plug this in the, so if I plug this in, then what do I get? If I plug this in, then your CBC, CdBC over dt equals negative VC over R plus IL, right? I just plug this in. Then similarly, what is the next one? DIL. I just plugged in the value of IC and BL, right? So that's what I did. So now this guy is negative BC plus BT. Okay, so from here, how do you get BC? dVC over dt, or derivative of VC with time. What do you get from here? Can I say this is simply divided by C, both sides? So this C and C cancel out, then what do you get? Negative BC over RC, or CR, whatever you call it, plus IL over C, right? This is equation 1. So how about here? What is your DIL over dt? So divide both sides by L, right? That gets rid of this L. Then you get minus BC over L plus BT over L. Does it make sense so far? So our goal is to write in terms of this, right? Our goal is to write in terms of x dot, in this form rather, AX plus BU, and Y equals CX plus D. So this X and this X same, okay? And this is X dot. So how do you write this guy? This guy these two in this form first. Okay, let's write that down. So your x is what? Your x is BC IL, right? That's your x. Okay, then, so how do you write this guy now? So you have BC, dBC over dt, DIL over dt. This is your left hand side. This is x dot, right? This is your x dot now. Now equals, then what is your A? Find out A, find out x. X is already there, BC, IL is your x. Then you have to find B and U. U is what? U is B, right? The source. So you have to find B and A. So here, what is your A? BC times, see this you have to do here, something here and something here. BC times this guy and IL times this guy, right? So what should you do here? BC times what? Here. Help me here. BC times what? Negative 1 over CR. Then IL times what? Help me here. 1 over C. That gives you the equation 1. So how about here? So then you don't have BT here, right? So this means it should be 0 here. You don't have BT in the first one. That's why this is 0. Because you have to add all the, these guys together, right? From here all the way, this thing. So then similarly, what is here? BC, this guy, again goes here, right? BC here. BC times negative 1 over L. Then what is the next one? You don't have IL term, right? So that's why this is 0. Then how about here? But here you have BT times what? BT times 1 over L. That's why this becomes 1 over L. This is how you do it. That makes sense. Question. Now we have to do this Y now. So Y is what? So what is your output variable? Let me go back here and see what is your output variable here. Your output is given. Output variable is current through the register IR. Okay, that's your output. So now you have to write the IR in terms of, if you can, in terms of all those three variables and variables and input. So what is your IR then? IR equals, so your X is same, right? See, this X is same. X is, help me, what is your X? BCIL plus, what is your D? We have to figure this out, okay? D and C. So IR, so what is the formula for IR? IR is BC over R, right? That's your IR. Oops, IR. Okay, there. IR is BC over R, right? See that? So then what do you get here? So multiply BC multiplied by 1 over R, right? That gives the first one. Second one should be 0 because there is no IL here. Then what should be the D one here? D is again 0. So this is your output equation. This is 4, this is 3. This is your matrix. So system matrix, right? We call it system matrix. This guy, this is A, which is system matrix. The question is why we are doing all of this. So we haven't found anything yet, right? So we are trying to find the differential equation here. First, you have to remember when you do in engineering or whatever, physics, first step is to set up the problem. Okay, we set up the problem in terms of derivative. See, now next step will be solve the problem. So we are in this phase right now. We set up the problem, then we solve the problem in chapter 4. This is our chapter 3. In chapter 4, we'll solve the problem, okay? So chapter 3 is all about setting up. Question here, please. Guys, any questions so far? No? Okay, now let's do this again for this system. Now we are coming to the mechanical system. So mechanical system, we have, so what are the three components? We have mass, spring, and dashpot, right? So we have three components in mechanical system. So this is the simplest mechanical system. Now, we know this is energy storage device, right? This is energy storage device. But in the case of mechanical system, so energy storage method is not easier. You can still do it, but it's not easier. So let me do the easy method, okay? So what I'll do is just, first of all, I'll do the free body diagram of this guy. Free body diagram. So how do you do the free body diagram here? So look at the, now I'll take you back to chapter 2. So here, so you have the mass, right? You have the mass M. So units on the left, this is the displacement to the right. That's why the spring is stressed and it has the capacity to come back to the left hand side. That's why this is your spring force Kx. So what is this guy? This guy is again to the left. Fb x dot. Then you have again the MA, right? M double dot on the left. So on the right hand side you have Ft. This is your free body diagram, right? So what is the equation of motion then? So sum of all forces equals 0, right? Or you can D'Alembert, right? Sum of all forces minus MA equals 0, right? MA. So that means, or you can say F equals MA is the same thing, right? So then summation F. So what are all the forces here? All the forces to the left, right? So all the forces to the left. So did he use this or that? I think we use this one, right? So let's not worry about this. It's the same thing, but I want to be consistent. Otherwise, it might mislead. It might be misleading. Okay, so summation F is Kx to the left, which is minus Fb x dot to the left minus Mx dot to the left. Then what is to the right? Ft to the right. Oh, minus Ft then equals 0, right? Yep. So that's your plus Ft, sorry, plus Ft equals 0. So these are the three forces. Then this is MA. Okay, equals 0. So what is your thing?
Pardon me, Professor. Quick question. Why is our mass moving in a negative direction? Doesn't X mean it's moving forward?
Okay. Remember we did the inertial force? Okay. So in chapter 2, what he did is MA is this way, right? Okay. But the thing is, our goal is to make it 0, right? See? Entire thing is 0. So now I'm applying this virtual force equal to this one. I call this virtual force. I apply the force equal to MA. Then, so how should I apply this MA so that my system is in equilibrium? To the left or to the right? So my goal is to make it 0, right? See, right hand side is 0, meaning my entire system is in equilibrium. Even though this guy is moving to the right, my goal is to make this in equilibrium. That's the D'Alembert principle, right? So,
Okay.
so my goal is to make the system equilibrium by applying. So how much force I should apply to this guy so that this guy is in equilibrium? Negative MA. So in that case, my MA is gone and I have a negative MA. So that my system is in equilibrium.
I see. Okay, thank you. Sorry about that.
Okay, no problem. Yeah, you're always welcome. Okay, now, so here, see what do you get here? So here, MX, so what do you get here? FT equals KX, right? KX plus FB, X dot, sorry, plus MX double dot, right? Or if you want, I can write this, okay. Can I erase this now? Let me erase this one here. I don't need this anymore, right? So let me erase this. So let me rewrite this guy as this. My FT is KX plus FB dx over dt plus m d square x over dt square. Okay. Now, okay. Now in this case we choose the state variables. The displacement is state variable. Then the other one is derivative, right? Let's say you have state variables x1 and x2. My x1 is x. My x2 is dx over dt. Remember, x and dx, they can be state variable. They are linearly independent, right? And can be state variable. So this is my x, one of the state variable, and the velocity, which is dx over dt. These are my state variables. So my x1 is, x1 is x. My state variable 2 is dx over dt. So now, so how do I write this guy then? How do I write this guy in terms of state variable? So ft, right? Ft equals, so k, what is this? K is k, what is x? X is, now you have to do everything in terms of x1 and x2. That's the thing. Okay, is this x1 or x2? Is this k x1 or x2? X1, right? Then plus fb, is this dx over dt x1 or x2? X2. So then plus m. So is this guy, how do I write this guy? Can I write this guy? What is this here? X2? Does it make sense? So now what are my two equations then? My two equations are this. Equation 1, dx1, because this is, I can write this guy as dx1, right? dx1 over dt, because your x is x1, right? See, x is x1. So dx1 over dt, that's my one equation, equals x2. That's the equation number 1. What is my next equation? My next equation, can I rewrite this guy here? I'll write this like this, m dx2 over dt equals this guy. Then take it to the other side. So you have minus kx1 minus fbx2 plus ft. I'm rewriting this guy like this. Then you have to divide by m, right? Both sides, so that I will get dx2 over dt equals, what do you get here? Divide by m minus k over m x1 minus fb x2 over m plus ft over m. Does it make sense? Now you have two equations. Guys, question here, please. I need your help.
Can you go over how you got equation 1 again? Oh, well, yeah, that's just the x2 equals dx dt. Okay.
Yeah.
Gotcha.
So now our goal is to rewrite this in terms of matrix form, right? In matrix form. So you have to write in this form: x dot equals ax plus c, right? Ax plus, no, x plus bu. Sorry, why did I say bu? Right, in this form. So what is your x dot? Your x dot is x1 dot x2 dot. That's your x dot. Then what is your a? We don't know, right? We don't know. What is your x? x1, x2 is your x. What is your b? We don't know. What is your u? U is f, right? U is f. So let's figure this out. So from here, x1 dot equals x2, meaning what is this guy? This is 1, because x2 part is 1, and this is 0, and this is also 0, because there is no f here, right? No f, no x1. That's why this guy is 0, this guy is 0. Now how about here? Help me. I have x1. What is x1? X1 is negative k times negative k over m times x1, right? So that's what it is. So then what is the x2? Negative fv over m. Negative fv over m. Then what is your here? Then you have 1 over m ft. 1 over m. Does it make sense? Guys, so far so good.
Yeah.
So now what is your output equation then? Output is what? What is your output here? So xt is the output. This is your output. If this is your output, then how do you write xt? So x means x1 is your output. See, your x1 is your output. So x1 is the output. X1 equals, how do you get x1? So what is the formula? What is the form of x output? Can you help me? Y equals cx plus d, right? So your x is there. X is x1, y1. Sorry, x1 or x2. Then what is your d? What is your c? What is your c? X1 is x1, right? So that's why this is 1, this is 0, this is 0. This is very simple. So your c is 1, 0. And d is 0. Okay, this is very easy to understand because xt is output. This is what happens, right, in this system. This is your input. You apply the force, right? That's your input. What do you get as a result? You get output, which is xt. It's very intuitive in that sense. It's very easy to understand the concept. So you have the input ft, apply force, which is input. Then what do you get? You get xt, right? So you get output. So now what I'm trying to do here is, what I'm trying to put here, now next step, what I'm trying to show you here is state variable representation is not unique. Okay.
Sorry to interrupt. Could you go back one slide for just a second? Wait a minute. Okay. No, it's just when you moved forward now again a couple slides, your equation was that for the same system or did you just skip over something? Because I just thought I saw something different on there.
Oh, this is the same thing. Just I did it here, but I wanted to hide it.
Yeah, well, I just thought you had a different final answer for one of these than the other, but maybe not.
Okay, so where did you find that?
No. So maybe not. I think it was just flashed before my eyes so quickly. So the very bottom part, the y equals, you have 1 over k.
Yes, that's what I'm going to talk about now.
Oh, okay, sorry.
That's okay.
Because I saw it different and I was like, oh gosh, is there a mistake or something? So, all right.
Thank you. Yes. So now what I'm trying to do here is, now state space representation are not unique. State space representation are not unique. That's what I'm trying to prove here. Okay. So we did the same problem last time where my x1 is x and x2 is dx over dt, right? That's what we did. Now what I'm trying to do here is I'm going to choose different x1 and x2. Let's say my x1 is, let's say, I don't know, kx instead of x. Then x2 is, I don't know. So my x2 is, let's say, fv times dx over dt. I choose this. Still the system works, okay? So what I'm trying to prove here is state space representation is not unique. You can have different representation. Instead of x1 equals x, I scaled it by k. Instead of dx dt, I scaled it by fv. Now, these x1, x2 are the scaled version of these guys. Then what is your dx1 or d2 here? What will be your dx1, d2, dt? K dx dt, or I can simply say k dx k. So how do I write in this form? So from here, what is your dx dt? x2 over fv k. So k is k. What is your dx dt? x2 over fv, right? That's my equation 1. Then what is your dx2 dt? Now we need that, right? dx2 dt. This is second equation. So from here, what do you get dx2 dt? So if you, this is your thing, right? This is your thing. From here, if you do the derivative of this guy, what do you get? Take the derivative, then you get fv d square x dt, right? That's your x dx dt2, dx2 dt. Then what is your so how do you write this guy now? So what is your d? Now, you know, this so from here, dx to dt, so here. So what is your d square? Let me take it from other previous slide. Now we know what is your, we can find this, right? What is your equation of motion? That's what I'm trying to get here. So d square x, this is the equation of motion, right? D square dt square equals, what do you have? F over m plus fb over m dx dt plus k over m x, right? This is your equation of motion. I just multiply, divided by m, right? That's it. So d square dt square equals fp over m. So, oh, this is minus, right? These two are minus. Right? Any confusion here? What I did here? Guys, does it make sense? This guy, how did I get this? Does it make sense?
That was from the previous step of
Equation of motion, right?
before. Yeah.
Equation of motion,
You're
right?
just dividing by m on both sides.
Right. So then, but here you have fb times this guy. So you have to do fb again. Multiply both sides by fb. What do you get? So this is fb, right? No, this is force, ft. So ft, fv. You have fb, ft. This d guy over m. Then what do you have next? fv squared over m dx dt minus k fb, right, over m x. Does it make sense?
Yeah, it makes sense.
Okay, now what is your then? But these guys aren't in the form of x1, x2, right? Now your goal is to write this guy in terms of x1, x2. How do you rewrite in terms of x1, x2? So fb, ft, there is nothing you can write here, right? There is no variable. Then how about fb square? You know what I would do? I'll do this guy fb times fb. So then one of the fb goes with this guy and makes this guy here x2. So in that case, fb over m x2. Does it make sense? Then here minus k fb over m. Your x is what? Oops, sorry. Kx. Kx is your kx. There is no k here. Kx is your x1. This is your x1. So you have two equations here. So this is your second one, dx2 over dt. Now how do you write in the matrix form now? So you have two equations here. This is so bright, too red. So here, this is one of the equations. And this is another equation here. How do you write these two guys in the matrix form? So dx1 over dt, dx2 over dt, that's on the left hand side, equals, so you have ax, right? What is your x? X is x1, x2. Then bu, right? You have b, then u. What is your u? I think u is ft, right? U is ft. Okay, now let's figure this out. So what is your dx1 dt? So go it from here, which is this guy, right? So x2 is there, the first one is 0. First one is 0, x2 is k over fb. Then for this one, what is your thingy? X1 is this, negative, negative, negative fb or, hold on. Did I make a mistake here? Minus k over m x1. Minus k over m. What did I do here? What is this? K over fb. Then what is here? I'm confused here. Minus fb over m, right? Help me, guys. Fb over m. Yeah, this is your fb over x. Then what is this guy here? Minus fb over m again, right? Fb over m. Then what is your ft? Ft is fb over m. Fb over m. Then what is your ft here? 0, right? So you have no ft here. So this is done. Then what is your output? So xt is output, right? Xt is output. So how do you write the x2? So x2 is, sorry, x is output. So x is output from here. From here, what is your x? X is x1 over k. Okay. So x1 over k. You have to have x1 over k. So your x equals something times x1, x2, right? Then what do you have here? Your x is x1 over k, right? So 1 over k here. And this is 0 because there is nothing, no x2 term here. So then the other one is 0 because you already had the x1 over k. So then 0. This is your output equation. So remember, this output equation and this equation are different from the other previous one, right? It means state space representation are not unique. Depending on what variables you choose as state variables, your representation will be different. It's not unique. Guys, make sense so far? Question here, please. I'm ready.
Is that a 1 over a k when in the output equation x equals, it's parentheses that 1 over k.
It's 1 over k0.
K0. Yep, thank you.
Can you go over again how we're getting the elements in matrix A again?
So do you want me to go over equation 1 and 2 or from 1 and 2 to here?
From 1 and 2 just to there again,
Okay,
particularly for matrix A.
that's fine. That's fine. Okay. So you have, let's do this. So let's focus on this guy first, right? This guy. So in this guy, so this guy here. So you have to have dx. So left hand side not problem, right? Because you have x dot. X dot is your x1 dot x2 dot. That's your x dot. So that's why you have x1 dot x2 dot. Left hand side is not a problem, right? The thing is how to get this guy. So let me erase this again and let me figure out. So far it's not a problem because this is x and this is your u, right? B u. This is your b. This is your a. A x times b u. That should be the format. Now, so to do the dx dt, you have to rely on this guy. So let's see. So this guy is what? You just have x2, right? Nothing, there's no x1 here. That's why, so this x1 multiplies with this guy and x2 multiply with this guy here, right? Remember when you do the matrix multiplication? That's why x2 is multiplied by 0, x1 is multiplied by k over fb. That's why you multiply this together, you get k over fb x1. Oops, I made a mistake. Other way around, right? Sorry. So x1 is 0, x2 is k over fb. I should have done that, right? Then equation 1 is done. Now I don't have to worry about this guy. This is done. Now let's take a look at this equation 2 here. Equation 2 is this guy here. Now from equation 2, how do I get the bottom part? So dxt over dt already there. This is dxt over dt already there, right? Now you have to get the x1 times what? X1, what is x1? X1 times this guy. So minus fb over m. X1 times, then x2 times this guy, which is minus fb over m again, this guy. Okay, then what is your b? B is, so in the first one your b is 0, in the second one your b is ft times fb over m. Fb over m. Why did I call this 0? Because in this equation there is no ft. That's why ft times 0 is 0 here. Does it make sense?
So everything here makes sense except for one thing to me. And that is in the A part of that, the k over fv. Where is the k coming from? If isn't the k already like incorporated into x1? Why do we have k there? K over fv.
Oh, so do you understand this? So you have, so do you, if you understand this equation 2, so let me try to make you understand equation 2 then. So do you understand? So let me see. So we know this is equation of motion, right? This way.
Yeah.
So now here, what is your dx2 over dt? This is your dx2 over dt. Then it means to find dxt over dt, you need to multiply by fb. Multiply fb to d square x dt. That's why we have to do here, FB, multiply by FB. Then if you multiply FB throughout, then what do you get? You have to multiply FB by throughout. So then if you multiply FB throughout, then what do you get? So we had ft over m minus 1 over m. Oh, you have FB here, sorry. You have FB over dx, then k over m. So multiply this guy throughout by FB, then you get FB here, then FB square here, FB here. If you multiply this guy by FB, you get this, right? Does it make sense so far?
Yeah, I understand how we got to equation 2. But like I guess I just don't understand when we're turning this into the matrix form. Like,
oh, okay.
The A. So you were just going over how to turn that into the matrix form with the other student right before me.
Mm-hmm.
And like I feel like I get it, except for the K over the FV. I just thought that term would be 1 over FV, since the K component of that, I think, isn't that already part of the definition of X1?
Oh, this K, right?
Yes, that's correct.
Okay, I see. Now the thing is this. Okay, this is a very good question. All right, let's do it here. So here, your x2. So you have to have your dx1. What is my dx1 here? Do you see that? This is my dx1, right? dx1 is k times x2 over fb. So there is no x1 here, right? There is no x1. That's why this is 0. So this gets multiplied with this guy. This multiplied with this guy, right? That's why your x1 is 0. There is no x1 here. x1 term vanished. Then x2 term, what do we have? This x2 multiplied by this guy gives you this guy. See that?
Okay, thank you.
It's not coming from 2. Yeah, you're right. It's not coming from 2. It's coming from 1.
It's coming from 1. Oh, okay, thank you.
Yeah. All right, very good. So let's move on. Okay. All right, let's do one more. Problem here. So find the state and output equations for the electrical network shown in figure. If the output vector is, now you have output is the vector now, okay? So it used to be only 1, right? Now in this case, my output is two quantities. So when I'm writing this guy, I can rewrite this guy as this, okay? Don't be confused with the BT. VR2, IR2. So this is same thing as this, okay? I'm writing this guy like this. Here I'm writing like this, okay? So that's why I have T here, transpose, right? My output is this. Now my equation, my system is like here. You have the current source. Instead of voltage source, you have current source here, and you have a current source again here. Then you have the resistor R1. Then you have inductor. Then you have the capacitor C. Then you have R2 connected like this. So how many equations do you expect from this diagram? How many energy storage element do you see here? Just 2. So one is C, the other one is L. These are the energy storage element. So these R1 and R2, they are not, right? So that's why I expect 2 energy storage I expect two differential equation for each state variables. One state variable corresponding to this guy, the other state variable corresponding to this guy. So for this guy, for the capacitor, how do you write the differential equation? So IC, meaning current through the capacitor, IC is equal to C dVc over dt, exactly as before. We did this exactly as before. And similarly, for the L component, what do we have? The voltage across L is VL is equal to L DIL over dt. So actually, both of these two are they already introduced in the previous problem. Okay, this is exactly the same equation we had before. These two equations. So these two. Now from here, what did you realize is you have two state variables, BC and IL. These are two state variables. Now your goal is to write this IC and BL in terms of state variable. So IC in terms of BC, BL, IL, and input, there are input here. Okay. So, and also same thing with this guy. Oops. Same thing with this guy. So that's our goal. Okay, let's do that. So let's write your BL first. So let's begin with this BL. So how do I write this BL in terms of IL and BC? So BL, what is my BL? What is my BL? Help me. Here, right? So BL. So BL and BC, right? So which circuit do you think I should take if I want to express my BL? I want to express BL in terms of BC and IL. Which mesh you have to take? This mesh, this mesh, this mesh, or this mesh? I think I have to do this one, right? Because you have BC here. See, you have BC here, you have IL here. Okay. So that's why I want to do this around this loop. So in this loop, what do I have? You have BL here, right? BL. Then what do I have here? You have BC. BL plus BC. Oops. Let's not do anything. BC. Then what do you have here? IR2, R2, right? Does it make sense? So then what is this guy? From here to here, you are going uphill or downhill? Uphill, right? Because the current is flowing this way, you are going uphill. This is plus. So from here to here, you are going uphill or downhill? Downhill. From here to here, you're going downhill. That's why this is minus. Then what is your BL from here? Your BL is BC plus IR2, R2. Does it make sense? Does it make sense so far? So BL equals BC plus IR2 R2, okay? So try to remember that, or I can rewrite it. Okay. So what we have from the previous slide is BL equals BC plus IR2 R2, right? That's what I have from the previous slide. Okay. So then now let's use the Kirchhoff's law at the node 2. So what do you get? So at 2, what is going in? You have IC there, you have IR2 there, then you have 4BL there. This is the current, which is equal to 4BL. This is the current, and this is the current, right? This goes here, this comes out of that, and this goes towards that. Okay, so ingoing, this is ingoing, that's why this is plus. This is outgoing, this is minus. This is ingoing, this is plus, equals 0. So IR2 equals, what do you get? IR2 equals IC plus 4BL. Okay, so let me write this here in nice form here. So this is my thing. I wrote this there. Okay, so now I have this guy here, and I have this guy from previous slide.
So I have a question real quick just about the diagram. So like, is the triangle, so the triangle symbol with the arrow, that represents a current?
Yeah, whatever you see this, you see the,
Or not triangle, diamond shape.
yeah, this is current. Wherever you see this arrow,
Yeah.
this is the thing, that's the current, okay?
Right. But is there a difference between when it has a circle around it or the diamond around it? I just don't know if that's, does that mean anything different, or is it, they're both a representation of that, that's a current there?
That's the current.
Okay, thank you.
So here, so now the thing is, so this is my, from the previous slide, right? Let's see, plug in the value of BC. So what is my BC? BC is BC. Then what is my IR2? Plug in the value of this guy here. This guy goes in here. IR2, then R2. What do you get? So BL equal BC, R2 times IC4BL. Okay, this guy written is nice form here. So far so good, right? Now this guy, how do I rewrite this guy? So BL equals, because I have BL here. You see that? You have BL here. So how do I write this guy? BL minus BL. So what do I have here? If I bring it to the left side, what do I get? Help me here. Minus R2. Oops. 4 R2 BL equals BC plus R2 IC. Does it make sense? I'm rewriting this guy as this. So BL is BL, and you have R2 4BL to the left. Okay, then BC and R2 IC. BC and R2 IC. Does it make sense? Then you have BL, is a factor out BL here. 1 minus 4 R2, factor out BL, equals BC plus R2 IC. Then what is your BL? BL is 1 over 1 minus 4 R2, then BC plus IC R2. So this is written nicely in this manner here. This is the same thing. Does it make sense? All right. So now let me use the Kirchhoff's law at the node 1 here. So node 1 here. So what is the Kirchhoff's law here? What is your IC? Because you have your BL already. Okay. So remember, you have BL, then IC, right? So BL and IC. So you already have BL in terms of, now what? So what is your IC? So what is your IC now in this, at this? So use the Kirchhoff's law here. What do you get there? Help me here. So you have this guy going in, IT, and you have this guy IR1T, then you have ILT, then you have IC, right? IC, right? What is it?
I don't really understand how you get IC at node 1, but yeah.
So you have, so this guy has how many things? 1, 2, 3, 4. So this guy has 4 things here. 1, 2, 3, and 4. 1, 2, 3, 4. Does it make sense? So IT, you have IT there. You have, what else do you have? IR2, this guy. IR1T. Then you have this guy. ILT. Then you have IC. Does it make sense?
I guess. I mean, you can keep going. It's fine.
No. What's the problem? No. I'm okay with
No, it's fine. Keep going. It's all good.
it. Yeah. So this guy is going, this is at this node, this IC is going into it. So that's why it's plus. So this guy is going out, this is minus. And this guy is going out, this is minus. And this guy is going out, this is minus. So then your IC, you need to find IC, right? What is your IC? ICT equals IT minus IR1 minus IL. There. Okay. So now my variables, remember what are my variables? Help me. BC and IL, right? BC and IL. Let me, BC and IL. These are my variables. So here, so this IR1. So this guy, how do I write this guy? Can I write this guy like this? IT. So IR1, this guy here. Can I write this as DR1 over R1 minus IL? Then again, I'm going to write this BR1 as, is my BR1 same as BL? BL. See, I'm trying to relate here. Okay. So B, let me rewrite nicely. IT minus this guy is BL over R1 minus IL. Okay, I call it equation 2. And this is equation 1. Let's solve equation 1 and 2, meaning this is IC, right? So let's plug this IC in here, this guy. Then what do you get? Your BL, this is your BL, okay? Then 1 over 4, this is your this. Then BC is BC. Then IC multiplied by R2, right? So IC multiplied, so this is your IC. IC is, they have multiplied by R2 throughout. So R2, 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 okay? So R2I, R2I, then R2 over R1, negative R2 over R1 BL, negative, right? Then negative R2 IL, there. So now, if I simplify this, I will get BL in terms of BC and IL. Okay, let's do that. How much time do we have?
I think we're out of time, actually.
Really? Should I stop it here? Okay, I'll stop it here, then I'll continue next time. Unless you have a question, I'm done for the day.
Take care, Professor.
All right, thank you guys, bye-bye.
Have a good one, sir.